Chapter 8, Alcohol Screencast 1. This is the first of 6 screencasts for this chapter, and as noted, the topic of this chapter is going to be alcohol. One thing to remember about alcohol is that it is considered to be empty calories. Another thing is that not all alcohol beverages have the same amount of alcohol or calories. Most beers have approximately 5% alcohol or less. This may change with some of the seasonal beers. Wine contains anywhere from 5 to 14% alcohol. Fortified wines will contain 15 to 22% alcohol. Distilled spirits typically are going to contain more than 22% alcohol. Another term to keep in mind here is how alcohol content is quite often listed as proof, and proof is twice the actual percentage. Table 8.1 lists alcohol and energy content of common alcoholic beverages. So here, one thing to keep in mind here is that many of these are considered to be standard sizes. But when you go to a bar, I'm going to use beer for an example. Quite often when you go to a bar and have a beer, it's going to be 16 or more ounces. And note, that is not one serving. It is actually more than one serving. So if we look at a regular beer, that is 12-ounce serving. So now imagine a can. There will be 12 grams of alcohol, and that is going to have about 150 calories. If we look at distilled spirits, typically now a serving is 1.5 fluid ounces. It is going to contain 14 grams of alcohol, and we're going to find 95 kcals in that drink. So keep in mind, that the amount of alcohol and calories is going to vary quite often. Now, one thing we want to remember here is what is considered to be a standard drink. A standard drink provides 14 grams of alcohol, so that will be considered standard. That would be a 12-ounce serving of beer, 5 ounces of wine, or 1.5 ounces of hard liquor. When we talk about what is defined as moderate alcohol intake, it is 1 standard-sized drink per day for women, 2 standard-sized drinks per day for men. Now, the production of alcoholic beverages has been going on for a very long period of time, and it is a result of the fermentation of grains, cereals, fruits, honey, milk, potatoes, or other foods that are rich in carbohydrate. How this works, yeast will actually convert carbohydrate to alcohol and carbon dioxide. Carbohydrates not in simple sugar form must be malted before fermentation. Each molecule of fermented glucose will yield 2 molecules of ethanol and 2 molecules of carbon dioxide. After fermentation, alcohol can actually be recovered from the product by distilling, whereby alcohol is boiled off and the vapors are collected and condensed. When we look at alcohol absorption and metabolism, it is important to remember that alcohol does not require any digestion or specific transport mechanisms or receptors, as it is lipid soluble. The stomach will absorb approximately 20% via simple diffusion, and the remainder will take place within the small intestine. If ingested with food, especially high-fat foods, the absorption of alcohol will be slowed down fairly dramatically. Alcohol is going to be found wherever water is distributed in the body, so extracellular, intracellular compartments, for example. And as noted, it easily moves through cell membranes as it is lipid soluble, but it does actually damage the proteins in cell membranes. Absolute priority is to metabolize, as alcohol cannot be stored in the body, and there are 3 major pathways in which alcohol is metabolized. One is alcohol dehydrogenase, or the ADH pathway, microsomal ethanol oxidizing system, known as MEOS, or the catalase pathway. Here we're looking at the alcohol dehydrogenase pathway. Alcohol will be converted into acetaldehyde, and acetaldehyde is going to be broken down by aldehyde dehydrogenase into acetyl-CoA. This will result in CO2 and energy, or a fatty acid. Now, one of the things to keep in mind here is when we are looking at the overall summary of alcohol metabolism, most of it is alcohol dehydrogenase pathway. That takes care of about 90% of alcohol, and basically it's going to be involved in low to moderate intake. It takes place in primarily the liver, but to some degree within the stomach. The Meos pathway takes place within the liver. This is a pathway that is involved when there is moderate to excessive intake, and this will actually increase with the increasing alcohol intake. We'll see more of this pathway taking over. The catalase pathway, this takes place within the liver and other cells. It comes into play with moderate to excessive intake of alcohol, and really is just a minor player in the process of alcohol metabolism. Now, there are a number of factors that will actually impact alcohol metabolism. The ability to produce enzymes is very key to alcohol metabolism. Ethnicity. Individuals of Asian descent have low activity of aldehyde dehydrogenase. It results in buildup of toxic acetaldehyde. Gender. Women produce less alcohol dehydrogenase. Women are smaller and have more body fat, less total body water, and age. Now, when the consumption of alcohol exceeds the liver's metabolic capacity, this is when we will see an increase in blood alcohol levels. This is going to be known as BAC. This is also when symptoms of alcohol intoxication will start to appear. Those organs that will very much demonstrate this are going to be the brain and nervous system as they are exposed to alcohol. As noted, blood alcohol concentration, or BAC, that is the amount of alcohol excreted in the lungs, is measured, and the alcohol content of exhaled air and blood are directly related. That's why you see a breathalyzer being used as an index of blood alcohol content. Here, we're basically looking at the approximate relationship between alcohol consumption and blood alcohol concentration. I'm not going to go through this chart, but you can use this chart here as an example. But one thing that I want to point out as far as the only safe driving limit is no alcohol at all. So I think that's really important. And so once again, it is important that you realize that the consumption of alcohol will greatly impair driving and other skills requiring a lot of coordination, etc. One thing to note here is females are also going to be more impacted by alcohol consumption. They will experience a greater increase in BAC, and once again, that's primarily due to the decrease in the amount of alcohol dehydrogenase they actually have. And remember, that is the pathway that is primarily responsible for the metabolism of alcohol. Now, if we look at things that can happen, with respect to acute alcohol toxicity, this is a dangerous situation and will require immediate medical treatment. You may hear to this referred quite often as alcohol poisoning. If untreated, it may result in respiratory failure or death, and there is also a greater risk of this happening when consuming distilled spirits. Another important term is going to be binge drinking. Binge drinking is defined as 4 or more drinks for women in a single session or 5 or more drinks for men. And this is something that we see much more often in a younger population, especially a college population. Now, here we're basically looking at what actually happens, as far as different types of impairment depending upon the blood alcohol content. When we look at 0.01 to 0.06, here what you're really looking at is a relaxed, slight euphoria, a sense of well-being, loss of inhibition, and less alert. There is slight impairment of judgment at this point of reason, memory, or concentration. Now, when we look at 0.06 to 0.1, you probably believe you are functioning better than you really are. You are still relaxed. There is less inhibition and more extroverted. This is when many will start to appear actually intoxicated. Now, what will be impaired is depth perception, reaction times, balance, speech, vision, hearing, reduced judgment, reason, and a decline in memory. When we look at 0.11 to 0.15, this is obviously intoxicated, not thinking straight, mood swings, vomiting. A sign of alcohol poisoning is common at these BAC levels. Motor coordination is significantly impaired. Reaction times are very much slowed down. You will be experiencing slurred speech, vision and hearing impairment, judgment, reason, memory suffer. 0.16 to 0.20, we're now looking at very incapacitated. Individuals may pass out and have memory blackout. Nausea and vomiting are especially common. There is a worsening in motor coordination, reaction time, memory, attention, balance, reason, and judgment. At 0.21 to 0.29, extremely drunk. These individuals will be in a stupor, may not feel pain, nausea, vomiting, may choke on vomit, may pass out. All mental, physical, and sensory functions are severely impaired. If we're looking at 0.30 to 0.39, you don't know where you are. There is a loss of consciousness that may take place, potentially seizures, danger of life-threatening alcohol poisoning. Many physiologic functions are severely impaired: slowed heart rate and breathing, hypothermia, hypoglycemia, and also loss of bladder control. When we look at blood levels greater than 0.40, life-threatening alcohol poisoning and death is likely with a blood alcohol level greater than 0.40. Now, as noted in the previous slide, the signs and symptoms of alcohol poisoning, they increase in also with the blood alcohol content. Some are going to be confusion and stupor, vomiting, low blood sugar or hypoglycemia. Individuals may become severely dehydrated. There is the potential for seizures. You also will see irregularities of breathing and heart rate. There may appear a blue tinged or pale skin. There is a drop in body temperature known as hypothermia, and in severe cases, loss of consciousness.